Every single time you send an email or buy something online, or even just browse the web, you're actually counting on this massive, invisible structure to keep. But before we start laying the bricks for our fortress, we've got to understand why it's so incredibly important. Because whether we see it or not, we are all right in the middle of a constant, unseen war. And this really says it all. This isn't a war fought on some distant battlefield with tanks and planes. No, the fight is for control over data, which is, without a doubt, the modern world's most precious resource. The attacks are absolutely relentless, and honestly, the stakes could not be higher. And believe me, this is not some abstract threat. Just look at this number. $10 trillion. That's the projected annual cost of cybercrime around the globe by 2025. I mean, it is a staggering figure that really shows you just how much is on the line. So what exactly is our fortress even trying to protect? Well, it all boils down to these three fundamental pillars, and they're all built on a bedrock of trust. First, you've got confidentiality. That's just about keeping secret secret. Second, integrity, making sure that data hasn't been messed with. And third, availability, making sure you can actually get to your stuff when you need it. Every single defense we're going to talk about serves one of these pillars. So how do we actually build the walls of this digital fortress? Well, it all starts with a foundation. This fascinating field that's, well, it's truly the science of secrets. And that science, it's called cryptography. At its heart, it's the art of turning information you can read into total gibberish, making sure that your communication is secure even if someone is listening in. It is the absolute bedrock of our digital fortress. Now, cryptography gives us two essential tools, two types of keys for our data. First up, you've got symmetric keys. Think of these like your house key. The same exact key locks the door and unlocks it. It's super fast, super efficient, but it creates a challenge. How do you safely share the key with someone else? And the brilliant solution to that problem is our second tool, asymmetric keys, which are kind of like a public lockbox. And this is where things get really, really clever. Imagine you just distribute thousands of open, unlocked mailboxes all over the world. That's your public key. Now, anyone who wants to send you a secret message can put it inside and lock it. But here's the magic. Once it's locked, even they can't open it again. Only you, with your one-of-a-kind private key, can open that mailbox. The system is amazing because it lets people communicate securely without ever having to share a secret key beforehand. Okay, so keys handle that confidentiality pillar we talked about. But what about integrity? How do we know for sure that a message or a file hasn't been tampered with? Well, that's where another crypto tool called hashing comes in. You can think of it as creating a unique, tamper-proof digital fingerprint for any piece of data. So check this out. On one side, you have an original contract that's run through a hashing engine, and it spits out that unique string of text. That's its fingerprint. Now, on the other side, if we change just one single thing, add a comma, change a letter, the new hash is completely, totally different. This is called the avalanche effect, and it's awesome because it means you can be 100% certain that the file you received is exactly as it was sent. So we've got our powerful tools, encryption keys, and digital fingerprints. But tools alone don't build a fortress, right? You need blueprints. You need a plan for how all these tools are going to work together. In the digital world, we call these plans protocols. And believe it or not, you see these protocols in action every single day. You know that little lock icon in your browser's address bar? Yep, you're watching the Transport Layer Security, or TLS, protocol do its thing. It's this carefully choreographed digital handshake where your browser and the website use all those crypto tools we just talked about to build a secure, private tunnel for your conversation. But hold on a second. This brings up a really big question, doesn't it? Okay, so your browser and the server can make a secure channel. Great, but how does your browser know it's actually talking to your bank and not some clever imposter pretending to be your bank? Well, the answer is this wonderfully elegant system called the chain of trust. At the very top, you have a small number of super-vetted organizations called root certificate authorities, or CAs. Think of them like digital notaries whose trustworthiness is literally built into your computer. They issue certificates to other CAs, who then issue certificates to individual websites. Your browser trusts the website because it can follow that unbroken chain of trust all the way back to the root. It's brilliant. All right, so our fortress now has a strong foundation and some really solid walls. But any good fortress also needs active defenses. It needs guards on the perimeter watching for any trouble. And these are our main guards. First up, you've got firewalls. They are the main gatekeepers, checking out all the traffic coming in and going out and blocking anything that looks malicious. Then you have intrusion detection systems, or an IDS. These are the sentries up in the watchtower. They don't block traffic, but they watch everything, and if they spot something suspicious, they sound the alarm. And finally, VPNs, which create an encrypted, armored tunnel for your data, so it can travel safely across a public network like the internet. Okay, so we have the foundation, the walls, and the guards. Let's put it all together now and see how this entire fortress works together to protect something we do all the time. Let's just trace a single online purchase. So first, you type in the website. The firewall lets you request through. Then that TLS handshake kicks in, using asymmetric cryptography to establish trust and create a secure channel. That's when you see the little lock pop up. As you browse, all the traffic is now protected with fast symmetric encryption. When you go to pay, your credit card details are encrypted, and hashing makes sure your order is sent perfectly. And the whole time, an IDS is watching the network for anything that looks fishy. See? Every single piece working together. And you know, this really brings us to what might be the most crucial point of all. Building this fortress is an incredible feat of engineering, but the work is never, ever done. Digital security isn't some product you can buy off a shelf or a fortress you build once and forget about. It's a living, ongoing process. So what you should really take away from this isn't just the tools, but a secure mindset that's built on these core ideas. First, defense in depth. Security has to be layered, like an onion, so if one layer fails, you're not totally exposed. Second, the principle of least privilege. Only give the absolute minimum access needed for someone or something to do its job. And finally, always remember that security is a process. The threats are always changing, so our defenses have to change too. Which leaves us with one final thought to chew on. Everything from your bank account to your private messages, your entire digital life is protected by a fortress just like the one we've explored. The real question is, are you ready for the siege?